अंतरिक्ष भौतिकी प्रयोगशाला के निदेशक डॉक्टर के राजीव का बयान सामने आया है। डॉक्टर के राजीव ने कहा कि असली फल चंद्रयान 3 की सुरक्षित लैंडिंग के बाद आएगा। उन्होंने कहा कि रोवर के पेलोड चंद्रमा पर मौजूद खनिजों के प्रकार को जानने में मदद करेंगे। उन्होंने ये भी कहा कि पहली बार हम जा रहे हैं, चंद्र रेजोलिथ की प्रोफाइलिंग है। और साथ ही उन्होंने ये भी कहा कि चंद्रयान 2 लैंडर अभी भी परिक्रमा कर रहा है और हमें डेटा मिल रहा है। आइए सुनते हैं डॉक्टर के राजीव का बयान।
Not basically for studying moon, I mean per se moon surface or something. It is for ranging between moon to earth ranging. It will have application even beyond Chandrayaan. It's only a reflector, retro reflector. The actual payloads are 3. One, the seismograph. Seismograph will measure any kind of, like in earth you have gravity, the perturbations. So these perturbations can be measured, like meteor is impacting. Moon surface is constantly getting impacted by meteors. So meteor impact it will be able to detect. Any lunar seismic activity it will be able to detect. In fact, it is so powerful, so sensitive that even the insertion of, we say deployment and insertion of the Chaste payload into the lunar surface can be detected by that. To that extent, it is sensitive. When you come to the physics payloads, one is the REMPA LP. LP is Langmuir probe. Langmuir probe will measure what is the plasma density in the atmosphere, lunar atmosphere. Moon has a very thin surface. Its concentration may be 10 power 8 times lower than at the Earth, even more. But it has. And this LP is able to measure it. But only thing is it will not be in neutral, it will be in ionized form because solar extreme ultraviolet radiations are directly coming there. So these will be ionized and lunar atmosphere. We say surface bound exosphere to be precise because it will be constantly escaping from moon surface. Can be measured. Plasmaspheric density and characteristics, concentration, temperature, energy associated, those things can be determined from Langmuir probe. There is the other payload is Chaste. It is for studying the lunar surface. There is something called a regolith. That is the top surface of the top layer of the lunar surface. That is thermally non-conductive, very, very non-conductive. So its top surface can come to say of the order of 30 degrees centigrade, but a few centimeter down, it may be of the order of minus 50, minus 100. This is what the calculations show, but nobody measured this. So we are going to measure it for the first time. What is the kind of profile that will be existing? So you have a probe that will be inserted into the lunar regolith. We will penetrate up to around 10 centimeter for probing. Actually 14 centimeter including the tip. The tip will be actually aiding us to penetrate. So 10 centimeter of the lunar surface will be probe. Temperature will be measured and basically it will give you the conductivity of the lunar regolith. This is very important for future applications because this regolith can be a building block for future space bases, lunar bases. So this property we need to study very well. So that's why we are taking this measurements. This is the first time that lunar regolith is measured. Apollo mission measured the temperature of the lunar interior, actually with a drilling thing. Once you drill it, the property changes. So you can still have it, but then they went to much deeper depth, not high profiling. They just look at the surface. That can be from any kind of measurement, including major measurements. But then they went deeper to 1 meter kind of thing. Not the total lunar regolith, they did not focus on that. Because they couldn't also, because they were going for drilling, and drilling will not give you any measurement of this. This Chaste is designed in such a way that it will not perturb the lunar regolith at all. It will slowly penetrate, very slowly. But even that can be detected by the seismograph. That is the sensitivity of the instruments. And these are also aided by our past missions. Chandrayaan 1 and Chandrayaan 2 are, studies based on that is substantially aiding us in doing this. For example, Chandrayaan 2 had an orbiter and a lander. Lander, of course, it was not successful. But orbiter is still orbiting, and we are getting data. And the payloads there is 100% successful.